All right. Hi, guys. So the first example problem here that I'm going to run through is just using some of the stoichiometry relationships in a with a neutralization reaction. Okay, this is practice exercise, excuse me, 4.15 from page 150 in your book. So the first part is how many grams of sodium hydroxide are needed to neutralize 20 milliliters of a 0.150 molar sulfuric acid solution. All right, so essentially what we're looking at here is the neutralization. You have to actually go through and we would need the equation for it, or at least the ability to recognize the stoichiometric ratio. So I'm going to write down the balanced equation just so you guys see where I'm getting the information from. Okay, so I'm going to do NaOH plus H2SO4, and this is going to give us, let's see, sodium sulfate. I don't know if that is, I'm going to look at my solution thing. I don't know if that's aqueous or not. It doesn't 100% matter, but should be consistent. SO4 is aqueous. Sodium, not an exception. So plus water. Okay. Balancing, we would need a, let's see, a 2 here. And a 2 here. And a 2. Wait a minute. Nope. That's it. Okay. All right. So we've got 20 milliliters of the 0.150 molar H2SO4. Okay. Now, you could use the molarity equation. Molarity equals moles over liters. You could do it that way, like get the answer from that and then plug it into the stoichiometry. This is what I was telling you the last part, though, is why I do dimensional analysis when I use conversions with this, with the molarity, because it makes it easier. I can do it all at once. So I'm just starting with this. So I'm going to start with I've got 20 milliliters, okay, of the H2SO4. Now, I'm not going to put the H2SO4 right away because I don't want to run out of room here. So I'm going to go from milliliters to liters. Okay. So now I'm in liters of the H2SO4, right? So I'm going to go, now I'm going to use my molarity as a conversion from moles, or I'm sorry, from liters to moles. I'm using this, the molarity, as moles over liters. Okay. Now I can convert, and I can go from moles of H2SO4 to moles of NaOH. This is the stoichiometric ratio, right? So the coefficients. Okay, so I get let's see, H2SO4, there's a 1 in front of that. There's a 2 in front of that. Okay, so these I get from the coefficients, right? Okay, then now that I'm in moles of NaOH, I can go to grams of NaOH. And grams of NaOH is 40. Okay, now I just do the math. And I get, okay, significant figures, 3 and 3, so I get 0.240 grams of NaOH. Our answer. Okay, so that's for part A. Now part B. How many liters of 0.500 molar hydrochloric acid are needed to react completely with 0.100 moles of PbNO3, forming a precipitate of PbCl2 solid? All right, so once again, we're going to need a balanced equation. Okay, so I'm going to do HCl needed to react with Pb to aqueous, forming PbCl2. They've already told us that that's a solid. Okay, which means, let's see. So what's left over then? The HNO3. So H is a +1, NO3 is a -1. So it's going to be HNO3. And I remember from my chart that all nitrates are aqueous, so that will be AQ. Okay. All right. So we have this, right? And balancing looks like we need a 2 here, and we need a 2 here. And that should do it. Yep. All right. So they've started us out with 0.100 moles of this, right? The forming a precipitate of this doesn't really matter in terms of this conversion. It just helps us on the equation. So I'm going to start with the 0.100 moles of my PB NO32. Okay, and then, so now, what do I need? Okay, well, I need liters of this, right, of the HCl. But remember, I can use this as a conversion. My mole here, this is like saying I've got 0.500 moles per 1 liter, right? So I can use this to convert from moles to liters. So what I really need to do is I need to find the moles of HCl that are needed to react with this. Okay, so I'm going to turn moles of PB NO32 into moles of the HCl. Okay, again, using my coefficients. So in front of PbNO32, nothing is a 1. In front of HCl is a 2. Okay, now I'm in moles of HCl, right? So now I can just use my molarity here as a conversion. So, but look here, I've got moles of HCl on the top, right? So moles of HCl on the bottom, liters of HCl on the top. Okay, so it's 0.500 goes with the moles and 1 with the liter, like that. Okay, now got liters, so I can just do the math. And let's see. This kicks me out significant figures. I've got 3 and 3, so it's going to be 0.400 liters of HCl. And that's all there is to it. Okay, so that's it for that one.